this video, we are going to review the calculation of surface area of 3D shapes. What is surface area? It is the area around the outside, or perhaps sometimes the inside, of a three-dimensional shape. For example, the amount of paper to cover a box, the bare minimum amount of paper to cover all 6 sides. The wall plus floor plus ceiling area of a room. If we're talking about painting all of the surfaces of a room, we'd paint the floor and the ceiling and all of the walls, and that would be the surface area of the room. The outside covering of a volleyball, which would be a sphere shape, and the minimum material to create a closed can, which would be a cylinder. The key to surface area problems is to practice using the formula. There are a bunch of different shapes, and each shape has a unique formula. Surface area formulas tend to be more complicated than volume formulas, so you want to be comfortable finding the values you need in each formula and using them a few times so that you're prepared to do those calculations. Here are the kind of shapes you might encounter: a ball or sphere shape, a cone shape. Notice that the cone also has a bottom here, not like an ice cream cone. So we would be considering all of those areas on the outside of the cone. A cube, a box or rectangular prism shape, a pyramid, and a cylinder. Let's take a look at a few examples. Here's our first, a rectangular prism. There's the formula. And we're being asked to find the surface area of that box. Notice this formula, as I said, is a little bit more complicated. 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Why is this formula so complicated? It's because we have sets of similar sides. This is the front, and then back here, we have a similar exact size, same size space on the back side of this box. So that's why we calculate that area, multiply it by 2. These ends are the same. This end and this end are exactly the same. So we have 2 of those. And we also have a top and a bottom that are the same size. So that's what's going on in the formula. We're calculating the area of one of them, and then we're multiplying by 2. It is important in a problem like this to label these. So I'm going to call this one length, I'm going to call this one width, and I'm going to call this one height. It's not important which one is which. It's just important that we keep them straight as we plug it into the formula. So 2 times our length, which is 4, times our width, which is 2. Length is 4, width is 2. We move on to the next part. 2 times our length, which is, again, 4, times our height, which is 3. And then we're going to add to that 2 times our width, which is 2, times our height, which is 3. So I hope you can see the importance of that labeling in keeping track of which value goes where. Let your calculator do this work, though. Multiply all of that and add it together, and you should get the answer of 52. I hope you have your calculator and you're following along. That's how you're going to get the most out of this. If not, pause the video and go get it. Let's move on to the next problem, a cylinder. There's the formula for a cylinder, and you can see that that's a little complicated. We're trying to find the surface area of that shape. We recognize it's a cylinder. We look up this formula for surface area, and then we find the value of the variables that we need. We know that we need the radius and we need the height. Here is our radius. If you are given the diameter, remember to divide that by 2. We always want the radius in formulas like this. So we have our radius and height, and we're ready to go. So 2 times pi, use your pi button in your calculator, times 2 times our height of 3. Then we add the second part, which is 2 times pi times our radius squared times 2 squared. Let the calculator do that work, and you should get the answer 20 pi. And that may seem like a strange answer to you, but when you use the pi button in the calculator, sometimes you will get the answer in terms of pi. If you want a decimal answer, as we do here, hit that toggle button above the enter key with the 2 arrows, and that will convert this to a decimal, which is about 62.8. So sometimes the answers will be listed with a pi in them, so you want to be able to have both forms of the answer. Example 3, we have a sphere here. There's our formula. It's actually pretty simple. What is the approximate surface area of the shape shown below? Our formula says we're going to multiply 4 times pi times r squared. And here is r. Now, we might have been given the diameter of this sphere. It would be exactly the same sphere if we were told that the diameter was 10. We divide by 2 and get the radius. And then we would proceed to substitute 4 times pi times 5 squared. Your calculator should give you 100 pi for that answer. Once again, it doesn't look like our answers are in terms of pi, so we hit the toggle button and we get about 314. Last shape, a cone. Now, this is interesting. We seem to have some extra dimensions there versus our volume. We have a height of 8, we have a radius of 6, and we have this dimension of 10. Let's take a look at the formula. 4 times r, which we know is the radius, times s. What is s? Well, this is what s is. And s stands for slant height. So it is that angular dimension up the side of the cone. And that's necessary in order for us to calculate surface area. Then we're going to add pi times r squared. Notice that there's no h in this formula. That means we need to ignore that value. We don't need it to find the surface area, even though they gave it to us. So let's substitute 4 times our radius, which is 6, times our slant height, which is 10. And then we're going to add to that pi times our radius, which is 6, squared. Let the calculator do the work, and you should get about 353. There is our answer. So the key takeaway here is that we have this extra variable called slant height, which only shows up in surface area of cones and surface area of pyramids. So just be aware of that one. It isn't explained anywhere on the GED formula sheet. All right, that's it for surface area. Now it's time for you to do some practice on your own.